Today I'd like to cover the ARM ULINKplus, which is the latest debug adapter available from Keil. This is designed to work exclusively with the MDK ARM and provide additional debug information for Cortex M microcontrollers. The ULINKplus has a number of novel features, and the primary versions of these are power measurement during debug. It also features digital and analog I/O, so we can generate and measure values down on the hardware. So this allows us to develop test scripts which allow hardware in the loop testing. The ULINKplus also has a couple of different isolation channels, so that the power measurement and the debugger are opto-isolated from the PC up to 1 kV. So the ULINKplus itself has a high-speed USB connection. So this is USB 2 high speed. And then the debug connection to the hardware is faster than most of the low-cost Coresight debuggers. So this is going at 50 megabits per second, which gives us a lot of bandwidth for the internal trace units. So we can capture a large amount of information, and this is all consolidated in a new view within the debugger. So this will show the execution of the code, so the operating system interrupts. We can also trace variable data into this system analyzer, and alongside this we can display the current and voltage that are measured as the code is executed. So this gives us a very detailed view of how our code is running on the device. So alongside the power measurement and the JTAG port, there's also an additional digital I/O port. So this gives us 8 lines of digital I/O and up to 3 analog inputs and 1 analog output. So these can be controlled within the debugger, and they're also available for scripting as well. So we can put signals down onto the target to stimulate the hardware, or we can measure values while the code's running and visualize those within the debugger. So it gives us a whole new dimension for our day-to-day debugging. So in terms of the debug connection, as I said, it's opto-isolated. So if we're using sensitive analog applications, we won't provide any additional voltage onto the target to disturb them. Or if we have a high voltage application such as motor control, we can ensure that we're fully isolated from it in case of any problems. We can also hot plug into a running target as well. So if we have a running application, we can connect the debugger and start to look at what's happening within the application. The debug connection that goes down onto the Cortex M microcontroller is a proprietary debug connection developed by ARM called Coresight, and this allows us to watch the internal memory locations, both of the data space and also the peripherals on the fly. So this is separate from JTAG, which doesn't provide you that kind of debug information. We can also set hardware data breakpoints and conditional breakpoints as well. So we can set up quite sophisticated debugging scenarios, both on the code and data locations within our application. The ULINKplus will also record the CPU clock frequency, and this is displayed in the system analyzer window. So you can ensure that you've set up the phase lock loop so the device is running at the frequency that you're expecting. And this will be shown dynamically as the code is running. So if you're changing the clock speed during application for energy management, you can see that dynamically changing, and you'll be able to see the power used as the clock changes as well. So again, it gives you a much clearer idea of what's happening to the device as the code's running. Also within the latest releases of the Microvision debugger, there's some new windows, a component viewer, so we can look into middleware stacks and provide a detailed view of the key variables that are within the Kyle middleware and the operating system. And you can design these windows for your own software components as well. So if you're working with a project over a long period of time, you can build up dedicated watch windows that expand out key structures or key global variables and break those down into a detailed view of the actual data. There's also a new event recorder as well, and this is a way of achieving an application type trace. So as the code runs, you can send up small amounts of information to the debugger, which will then expand those out into detailed runtime information about your code. This takes a little bit of work again to set up, but if you're working on a project long term, it provides you a very key insight into the low-level activity of your code. There is also a number of trace units that are built within the Cortex M microcontrollers. So it's a sort of minimal performance unit which will provide us information about exceptions and interrupts. And there's also a data trace unit which we can stream out information values that are being written into our key variables. And these are both non-intrusive, so as the code's running, we can stream out a lot of information to visualize within the debugger. So this is where the connection speed of the between the debug hardware and the application is quite important. So the low cost or virtually free debug adapters have quite a low bandwidth, but the ULINKplus and other ULINK adapters are designed to have a fast connection so we can stream out lots of information. There's also an additional unit called the instrumentation trace. This allows you to do printf style debugging, so you can printf messages up to the debugger. So you can think of this as a kind of a serial port within the debugger. And again, this is intrusive, but it is fairly minimal, and it allows you to send detailed information to a console window in the debugger. And again, we need a good performance of serial wire connection so that we can stream out a lot of this data. So in terms of the power management features, we can connect to our hardware just with a couple of voltage wires and a ground. And there are a number of shunts provided, so we can put a shunt board into the ULINKplus, and this will change the measuring range from 2.5 milliamps up to 250 milliamps. So there are a total of about 6 shunt boards provided. They're a little bit fiddly to put in on the front, and you have to be very careful not to lose them. But I've still it comes in a nice box and a little pouch, so you've got somewhere to keep them. These connect to a couple of internal A to D converters which have a high resolution and very linear behavior. This took quite a lot of time to achieve, but we can get down to about 200 nanoamps resolution. And once we've then logged the voltage and current data, these are all synchronized with the internal trace of the instructions and also the event recorder. So we can relate back the power measurement to the threads that are running in our operating system. Furthermore, as we're logging the power and current data, there are also selectable filters built into the debugger, so we can filter at various frequencies to get a better visualization of how the code is executing. In addition to the power measurement, there are up to 8 channels of digital I/O and 4 channels of analog data. So we can control these manually within the debugger, as we'll see later, but they can also be controlled through a script language as well. So we can build up test harnesses within the debugger to generate analog and digital patterns or to log analog and digital data off of the target. The Microvision IDE is also available with a TCP/IP socket, so external third-party tools can start to control it. Some more sophisticated test packages, continuous integration servers can start to execute tests and log data directly onto the hard drive. So we can build up automated test farms, put into Jenkins type CI servers to automatically run large batches of tests with the hardware being manipulated by the ULINKplus at the same time. So to take a slightly deeper look at how this works, the ULINKplus connects to the target through the standard Coresight Debug connector. So this is a miniature 10-pin connector. So if you're new to the Cortex M microcontrollers, there are a number of evaluation boards that have standard JTAG connectors on. But if you're designing your own hardware, there is a special sub-miniature 10-pin Coresight connector, which is the one that you should look to be fitting, not a JTAG connector. So there are 2 initial pins that are used to get a debug connection to the Cortex M microcontroller. So this is the serial wire I/O and the serial wire clock. So these are always available on Cortex M devices, but the streaming of the real-time data is done through a 3rd pin called the serial wire out pin. And how this is implemented varies between different silicon manufacturers. Sometimes it will be a dedicated pin, sometimes it will be multiplexed with GPIO. So when the debugger starts up, it may need to switch that pin from GPIO to be an actual debug pin. And previously, this has been done by a script which had to be configured within the debug setup. On the latest version of Microvision, these scripts are integrated with the software packs so that they will automatically configure these pins to be the serial wire out. So now within the debugger, there's an additional pack tab, and here we have pre-configured scripts that will set up the target to give you the best debug experience. So you don't have to fiddle about with the debugger wondering why things aren't working. You can go straight in and start using all of the sophisticated features. Once you're inside the debugger, the new features of the ULINKplus are available via a dedicated window, much like the peripheral view windows. So here we can set the digital and analog pins to be inputs and outputs, to be digital I/O or analog I/O. And if they're outputs, we can then manually set the digital values high or low, or we can set the voltage that we want to output to the target. So this can be done as the code's running, and we can also set up the power measurement as well. So we specify the shunt voltage that we're using, and then we can enable the power measurement. All of these values are also available through a set of virtual registers which can be accessed via the script language. So if we want to automate things within our debug session, we can write scripts, and then we can control the ULINKplus digital I/O and power management, power logging features via scripts by writing directly to their virtual registers or reading the values that are in the virtual registers. These can be linked to we can create buttons which we can then link these scripts to. So as the code's running, you can press a button within the debugger to toggle pins, to set analog voltages, or to set a sequence of scripts executing. So again, here we have similar registers for power management. So again, these can be set up automatically to configure the power management when the debugger starts. There are a number of script templates that are available with the ULINKplus. So these are installed directly into Microvision, and the scripting language is a very C-like language with direct access to all of the virtual registers and the debug variables within the your application code. The printfs will write to console windows within the debugger, and in turn these can be logged to timestamp files directly onto the PC. So again, we can build up test scripts, so we can execute a whole sequence of tests and log the results and date and timestamp them directly onto files within the PC. And this is very open-ended and quite flexible, and is going to be expanded in future versions of Microvision. The actual power measurement uses two 16-bit delta sigma ADC converters running at 20 megahertz. So this gives us a very high dynamic range. We're achieving almost 14 bits of resolution, and we get down to somewhere in the region of 200 nanoamps to see exactly what's happening on the target. So this gives us quite a detailed view of the current and also the voltage as the code is executing. As I mentioned before, if you want to change the current range that you're measuring, we can plug in a little external shunt board which carries the resistor and then just take the wires down on the target. So we just need to be able to connect to the target, and you don't have to continually be mucking around with soldering and unsoldering resistors onto the target. So there is a range of these little shunt boards, so a total about 6 in all, and depending on the resolution that we need, we just select the appropriate shunt, configure it within the Microvision debugger, and then we start the code executing. So all of the data that we're getting from the ULINKplus is then consolidated within a system analyzer. So at the top, we have the current value of the system clock. So as again, if we're changing the value of the clock during runtime, we can see that changing, and we can then see underneath the effect that that has on the voltage and current. So again, here we can zoom in and get quite a high resolution, so we can see the effect of different code running, or the effect of external peripherals on the microcontroller voltage and current as the code is executing. Below that, we have the operating system threads, so we can see each of the threads executing within the RTOS, relate that back to the current measurement. And we also have the, we can see the exceptions that are running on the processor as well. So all of this is non-intrusive on the processor, except for seeing the RTOS thread switching. That information is sent through the instrumentation trace when the operating system does a task switch. So there's a little bit of overhead in writing out to the debugger, but the interrupt measurement is done through the interrupt counters, which are updated and read by the debugger without any impact on the CPU performance. So really, we have very, very little impact on the code as it executes. If you want to completely remove the impact of the debugger, it's possible to do the current and voltage logging without the debugger connected. So as the code is running, we can just start to log in code and voltage. We won't get any of the information about the code execution, but we'll be running without any of the debug hardware connected. So you're getting completely standalone operation of your code and being able to see its power execution. The ULINKplus itself has two isolation regions that are rated up to 1 kilovolt. So the power measurement and the JTAG debugger are both fully isolated from the PC. So if you're working with high voltage electronics or sensitive analog electronics, the ULINKplus is as isolated as possible from the actual hardware. So in terms of the range of ULINK devices that are available from Keil, we have the ULINK which was the original ULINK debugger, which came out around about 2006 with the introduction of the Cortex M microcontroller. So it's a little bit long in the tooth now, but it provides a universal debugger for all the different manufacturers of Cortex M microcontrollers. It connects to all of the internal debug units, so the data trace, the instrumentation trace, and it has now up to 10 megahertz debug connection to the hardware. So that's a little limited if you're trying to log lots of data off of the hardware, but it's a serviceable debugger at a low cost. In the mid-range, we have ULINKPro-D and ULINKplus. So the ULINKplus has the power management and the logic, the analog and digital I/O measurement that we can put onto the hardware. And it also has a higher speed connection onto the hardware. So we can stream off data up to 50 megabits a second. So much faster than the ULINK So as we're doing all of our real-time data logging, we've got lots of bandwidth to log that data. The ULINKPro-D is a more advanced debugger. It has a higher bandwidth for logging data. And it's also a good target if you're working with Cortex A devices as well. So this works well with the DS5 tool chain. So this is a separate tool chain that really is used for application-specific devices that have Cortex A, typically running an operating system like Linux. So this provides quite a low-cost debugger for all of the Cortex M microcontrollers, but also Cortex A devices as well. And then finally, the ULINK Pro, again, has very high-speed debug connection. And this will also support logging of instruction data if your devices are fitted with the embedded trace macro cell. So this provides unlimited streaming instruction trace. So basically every instruction that's executed, we can stream directly onto the hard disk drive. So this gives us a trace buffer that's effectively the size of your hard disk. Once we have that data, we can display it as a trace buffer, but also the Microvision debugger has tools for code coverage and performance analysis. The only debug adapter that provides integrated isolation is the ULINKplus. The ULINK Pro and the ULINKPro-D are available with a standalone isolation unit if you need that.